Hello viewers, in this session we will discuss on volumetric strain. As you can see in this figure, we have an element of having dimension A, B, C, D, and the load is applied on face AB and face CD, which is a tensile force. So when these two forces are acting on this body, we need to analyze it for the volumetric strain. So volumetric strain, we generally do use the notation to demonstrate that strain in, for volume V. So for that, if I write it volumetric strain, so what is volumetric strain? It is change in volume to original volume, right? This is change in volume. The definition of volumetric strain is change in volume to original volume. Original volume. So now, what is original volume? Our aim is to calculate this volumetric strain. So we need to know what is change in volume and what is original volume. So original volume is nothing but length into breadth into thickness, right? So what is change in volume, right? Change in volume. Change in volume is nothing but final volume minus original volume. So now I need to know what is final volume. So final volume is nothing but when this load is applied on this body, it is going to change its shape. The shape is changed in the length direction, and in the thickness direction, and in the width direction, right? So because of this load, the other dimensions are changed. So what and all dimensions are changed? That is change in length, which is expected, that is L is the original length plus delta L, that is the extension of the length. Next, change in width. So change in width, what I can write? I can write this original dimension B. Because of the axial load applied in the direction of length, the width will get decreased. So that is why I will take this as minus delta B, because it is a uniaxial. So in the axial direction, if I stretch it, the volume will get reduced in thickness as well as in width. So that reduction is demonstrated in delta B, and that is minus delta B. Next one is change in thickness. The change in thickness is again T minus delta T, right? In this way we can write it. So now, once I know this change in length, width and thickness, I can compute this final volume, right? I can compute this final volume. So if I write it for final volume, so it is nothing but L into width, that is length into width into thickness, right? So this is length, width and thickness. So I need to multiply this to get the change in volume, right? Or nothing but a final volume. So to get the final volume, I need to multiply this change in length, change in width and change in thickness. This is nothing but the volume of that is changed, that is volume of particular material after applying the load. So now what I can do now here, I need to multiply these these terms to get simplified. So what I do, so I will multiply this term to this term and this term to this term, and again similarly this to this, and I will rewrite this equation for as a simplified. Okay, so now that is L into B, the first term, and next term is minus L into delta B plus delta L into B minus delta L into delta B. This is one term, and multiplied with this part, which is T minus delta T. Okay, so again I need to multiply this, I need to take this for a multiplication. So what I do, that is what I need to do, then I will need to multiply this whole term to T into minus T minus delta T. So this first term I will multiply L B T minus L B times delta T, this minus L delta B into T, minus into minus plus L delta B delta T, then plus delta L B into T, into this delta L B into T, and minus delta L B into delta T, then minus delta L delta B T, this minus into minus plus delta L delta B into delta T. Right, this is what the total multiplication. So once we multiply this, I need to look at the delta terms. So the delta B or delta T and delta L represents a very minute change in volume. So that minute change in volume can be neglected where two and more deltas are there in a single term. So here I have two deltas, right, and here I have two deltas, this is one more and this is one more, right. So these minute changes in length, thickness and width are eliminated, and the major terms which will be considered. So if I rewrite the terms excluding these cancelled terms, can be, this is like, this is LBT, this is LBT minus LB into delta T minus LB into delta T, next plus BT into delta L, that is plus BT into delta L, right. And what is another term which is remained, LT into delta B, that is plus. So what is that remain, LBT, this, there are four terms which are remained, right. So first term and second term, third term and this fourth term, LB into delta T, LT into delta B, BT into delta L, right. So this, so this term, and we got one more, what is that, BT delta L, LB delta T, then LT delta B. So delta T is the, delta L is the, delta B is the, and LBT. So this is what the final volume. This is what the final volume after eliminating the minute change in the dimensions, that is delta. So now what I write, I will write change in volume. Change in volume can be written as, I need to that is final volume minus original volume. So final volume is this one, so that is LBT minus LB times delta T plus BT times delta L, that is again minus L T times delta B. So only in the length direction it will be plus, and width and thickness direction it is minus actually, right? So as of you observe the signs, in the length direction it is plus and it is minus. So now this part is, it is minus. Okay, so after this we have the minus original volume, that is L into B into T. This is the original volume, right? So in this what I can write, it will be cancelled. The term which is remained with respect to sun, if I write BT times delta L minus LB times delta T minus LT times delta B. So now this is the change in volume. So now I need to take the main equation which we have, this one, the change in volume and original volume, right? So volumetric strain equal to, we have change in volume divided by original volume. So if I substitute that here, it is change in volume, this is change in volume, and original volume is nothing but L, B and T. Okay, this is L, B and T. So now if I simplify this term, so this LBT will divide to all the three terms which is at the numerator. So BT times delta L divided by LBT minus this middle term taken to LBT, and again the third term LT times delta B by LBT. So now if I have these terms, then this BT will get cancelled, this LB will get cancelled, this LT will get cancelled. So now after the cancellation, what it remains? It remains delta L by L minus delta T by T minus delta B by B, that is volumetric strain. So now still I can solve it for how I can solve it for, I can take this change in thickness and in the width with respect to length. So for this what I can write, so this part is linear in direction and this is lateral, right? So linear nothing but it is in a longitudinal direction and these two are in a lateral directions. So now I have this Poisson's ratio. So what does the Poisson's ratio says? Which we do denote in a mu, that is lateral strain to linear strain. Lateral strain to linear linear strain. So lateral strain to linear strain, that means it is nothing but this thickness part and the width part. So now what I can write here, so strain in a linear direction, strain in linear direction minus 2 times lateral, strain in lateral direction, right? This is one term and this is another term. These are two terms which are in a lateral direction. So now how I can write? I can write this linear direction, that is L by delta L as it is. For lateral, what I can write? I can write 2 times mu of, for the lateral dimensions are changed with respect to delta L by L, right? These lateral dimensions are changed with respect to delta L by L. So for this, what I can write now, I will take this delta L by L common outside and multiplied with 1 minus 2 mu, right? So this is what I can write, right? So now it is nothing but strain, that is volumetric strain when the uniaxial load is applied, means the only in x direction the load is applied. So in other part, if the z direction as well as in x direction if the load is applied, then this particular derivation will extend for 3 dimensions. So that I will discuss in the next session. Thank you.